Greetings to everyone, my name is Michael Vasquez Nieves. I am currently pursuing a bachelor degree in electrical engineering with a concentration in control system and also a minor degree in business development. I am in my 5th year and I'm going to be explaining the Ratheon Intelligence and Space Research proposal called the FPGA Accelerated Obstructed Phase Identification. The team has 4 members. The first one is the business contact, Ken Pride, followed by the corporate mentor, Hector Irizarris, and then Professor, PhD Raul Torres, and finally me, Michael Vasquez. To be more specific, the coronavirus has spread across most continents, affecting the health of thousands of individuals. The World Health Organization recommends the population to wear masks as a protection mechanism against the virus. However, there are people who do not use the mask or use it occasionally. This has caused an exponential increase in the virus propagation curve. Currently, there is no technology that can monitor the use of masks in places with a high probability of conglomeration or where they are compulsory. In terms of public safety, recent years have seen an exponential increase in crime globally. Most of the people who commit some kind of crime use a mask to hide part of their face. Currently, there is no advanced system that can identify whether an individual who may commit a crime wears a mask or not. Value proposition. Value proposition is the value or the benefit that differentiates a product from the competition. For this case, there's no technology that can recognize a face wearing a mask. However, establishments hire personnel to monitor the use of masks when entering to the establishment. This solution causes companies to increase their payroll. It doesn't even guarantee that their security protocol will be fully complied. In terms of security, surveillance cameras are used in establishments to have a physical image of the offender. But the individual may cover their face, making the identification process more difficult. The proposed solution seeks to identify whether the face is covered or not to carry out an action. Solution to this problem is to master facial recognition. The research seeks to adapt facial recognition to solve common problems in society. The main objective is to develop a technology that can identify when an individual does or doesn't have a mask that covers part of their face. This could identify people who do not comply with the established security protocol. In the case of public safety, physical traces of potential criminals could be identified. I would like to add that currently China is revolutionizing the method of identifying people through facial recognition. This type of technology is having a great boom and is undoubtedly the future. Objectives. The research will be divided into tasks that will achieve the implementation of technology. First, a database of multiple individuals who have part or all of their faces covered will be generated. This database will be provided by Ratheon Corporation. The database will be synthetic, which will save time and cost. An algorithm will be developed using MATLAB. The model will be trained to successfully recognize people who wear masks. The algorithm will be executed in an FPGA. Programming will be converted to a VHDL for FPGA compatibility. The results will be simulated using Simulink. If the results are as expected, the implementation parts begin. The prototype will use a AP camera to capture the data and identify individuals who are wearing masks. The project will not be completed until a functional prototype is achieved and all the documentation is completed. The skills required for this undergraduate research are the following: machine learning, computer vision, programming, FPGA, and IP cameras. Requirements. The requirements are the following: use off-the-shelf AP camera fits as inputs to inference models, create models that can perform inference using an off-the-shelf FPGA, and create Datasets required to train the models. This is the timeline that sets the dates for each task. This timeline will soon be transformed into a Gantt chart. For December 1st, 2020, we will create a database of individuals with or without mask. For December 15, 2020, we will obtain the use of licenses and the programmable devices. For January 1st, 2021, we will start with the algorithm development. For February 1st, 2021, we will train the model with the synthetic data. For February 15, 2021, we will convert the MATLAB programming into the VHDL language. For March 1st, 2021, we will implement the programming in the selected FPGA. For March 15, 2021, we will simulate the behavior of the FPGA in Simulate. For April 1st, 2021, we will create the prototype. For April 15, 2021, we will train again the model with the real data. For May 1st, 2021, we will complete all the documentation required. The undergraduate research is sponsored by Ratheon Intelligence and Space Corporation and the University of Puerto Rico at Mayagüez. These are the references of all the images that appear throughout the presentation. Thanks for the attention.